Hello, this is Romeo Cat Computers, and today I have another assembly operating system. This one I worked on shortly after I was done with Fig Leaf OS, and if you haven't seen that one, I recommend you take a look at it, as it covers many ideas and things that made that work that also make this one work. But to put it shortly, this is something I coded in x86 assembly that runs natively and boots natively on IBM compatible systems using your typical IBM compatible BIOS, and it uses the basic BIOS interrupts. This does not run on top of MS-DOS or anything. This is its own thing. Now, instead of being terminal based, I tried to experiment with making more of a graphical interface. Now, you can't really, have windows drag them around and do things. It's mostly just, there's a set of icons that you can cursor over and select, and then they drop you into their own programs, most of which being text-based, using the text, like 80-column mode. But it was kind of a fun experience nonetheless, because it helped me learn a bit about the VGA 320 by 200 256 color mode. Anyway, first thing is the cursor and the way it's implemented. Now, it is not hooked up to operate based off of a real mouse, not a serial mouse, not a PS2 mouse, not a USB mouse, because the BIOS, the IBM BIOS, with its basic interrupts, does not have mouse capabilities. And I don't want to go digging around in the computer, in the memory addresses and the IRQs and whatever, figure out what mouse on what computer I happen to be using, because this sort of thing can be different. So if I run this on top of DOS one of these days, I'll make a newer one, and I might be able to get proper mouse implementation. But for now, the functionality of the mouse is mapped to WAS and D, and left clicking is enter. Now the problem is that it redraws the screen every time you move the cursor. And the problem is when I redraw the screen, it takes about 1 whole second, which is pretty terrible. Now, drawing stuff on screen in a virtual machine seems to mostly be a problem with my computer. It's like this even when I run Windows 2000 or Windows XP. It takes a little while to draw the screen. It's just pretty terrible here. When I run this on a real laptop or whatever, like some HP, usually it's a bit faster and you can move the cursor around. But for now, I have mapped all of the icons to 1 through 6 on the keyboard. So the first one is just power. It fades it out by redrawing the screen in several different shades of gray, getting darker and darker. And if I had a computer that wanted to function right now, then I could show you that in real life, but unfortunately, the Toshiba killed itself and the 486 didn't work to begin with, so maybe one day I'll show that. But anyway, number 2 is the terminal. And if you've seen the Fig Leaf OS video, you'll see that it's rather similar. In fact, I borrowed pretty much 95% of the code from that to recreate this terminal in the same style with the same functionality. Except if we go to HP help, which was carried over, you see we only have 2 options: to clear the screen and exit, which I'll do in a second. And that's just because it's like how Windows and Mac OS, they have terminal, but you don't typically use them. But they're there for, advanced capabilities and for power users and some older programs. I put the terminal in here just in case I wanted to add some terminal-specific functionality, and because, it was kind of neat to have a built-in terminal. But anyway, I never did end up putting anything in here, so that's all there is to it. And there's a terrible screen drawing again. Number 3 is a programmer. If you're familiar with the old 8-bit computers from the 80s, well, also the late 70s too, the Commodore PET 64, VIC-20, the Atari 400 and 8-bit, 800 and 8-bit computers, Apples, Tandys, Texas Instruments if you're a crazy person and had one of those. Yeah, poke and peek, you'd be familiar with that. And poke is to write to a memory address, peek is to read from one. So I'm going to write in the first address. Oh, numlock's not on. And I'm going to put, that is a character value for a filled in smiley face. Now I can peek a single address, and you can see I got what exactly I put in. And this is also in hexadecimal, by the way. Now if I can read a range here, and this will express it in a string of characters rather than just printing out the value in hexadecimal. And I'm going to read the first 512 bytes, so from 0000 to 0200. That's a bootloader. That's what all the ASCII character garbage is. The way the macOS bootloader works, which is what I'm using to boot the operating system, is in its function it puts itself in the first 512 bytes of RAM. So you can see this is the entire bootloader, and this is all assembly code, and you can see some of the little messages and stuff. And this is the very first one, and you can see it's a filled-in smiley face, as I have specified earlier. Now the execute was meant so that you could go up here, you could manually poke a bunch of assembly instructions into some open part of RAM, and then execute it. But I couldn't get the execution to work, and I will just like execute at the very beginning, and you can execute it anywhere. It will usually just take you back to the desktop. Sometimes it will do some other funny things, sometimes it'll crash the computer, but yeah, it doesn't quite work. A lot of these, I will mention, they were kind of just like, I made this as a little experiment. That's why it's called Z91. I didn't want to name it anything. I just kind of wanted to call it something, so I don't know, that was just a number that came into my head. So a lot of these things either don't work or are half done, but you know, they're kind of fun for me to put together. Number 4 is a color test and a display utility. Make sure your computer is capable of displaying the typical colors and character set in your BIOS. So here's the 320 by 200 VGA color test. It prints all 256 colors in a pattern onto the screen. As you can see, that works fine. We have the 80 column color text, which prints all 16 colors. Here's the character map, which could be handy if you have like an international computer or a more modern computer, because sometimes they do change the characters, the higher resolution ones. Here's the dreaded 40 columns that I hate, and if you don't know why I hate it, this is why. I mean, look at that, that's terrible. And then I can exit. And then number 5, we have a system information. If you're not familiar with the BIOS equipment list, I recommend, again, you go look at that other video. It explains kind of what's in there, but basically a list that you can read from the BIOS of some of the basic things you have plugged into your computer. This is expressed as just a hexadecimal value. If you want to convert that into binary and figure it out, go ahead. This is the RAM, and this also comes from a BIOS function to detect the maximum amount of RAM. And because it's the basic 16-bit BIOS, it only can detect up to 640K. So if you have any more than that, it's just going to detect 640. We get into a calculator here. Here's a programmer calculator, and I go in hex and I type 27F. You can see right here in decimal, that's 239, which is, or 639, which is 640 kilobytes. There is more RAM that you can access using some funny methods, but I haven't taken advantage of that. So here we have, speaking of RAM, this is the first 640 kilobytes of memory. And if you run that, then it will display the RAM as colors on the 300 by 200 or 320 by 200 display. So here's the bootloader up here. Here's some just miscellaneous garbage that made its way in there. And here's my little screen RAM for the desktop. I do have a screen RAM system for displaying things. And you can see it does write the icons onto the desktop, and then once everything is written, it will then throw it on the screen in one go every time it redraws the desktop. So I can press space to get out of there, and then exit. Next we have change the background. It's default light gray. We can set it to dithered blue. And now the problem with this one is that now the icons, they don't quite work. I'm going to press the power button when it finishes, but look, we're in the terminal. And that's because when I got the blue background, this icon is mapped here. This one's here, this one's here, and here, and here, and so on. So power button just disappears. I don't know if it just gets remapped down here or whatever, but and then so when I do that, it's just doing that for some reason. But I don't care because I have the number keys. And I can also change it to white, which, surprise, it's the color white. And a similar problem, it switches the icons around in a different way, but again, I don't really care all that much. But luckily, when you set it back to gray, everything goes back to normal. Finally, we have a paint program, which I never programmed. I was thinking that I wanted to try experimenting, seeing if I could create some sort of very rudimentary paint program using the 320 by 200 mode. But I had been working on this project for months and I kind of got tired of it, and by this point I decided I'd put everything into the OS that I wanted to. So the icon's there but doesn't do anything. So let me just show you the power cycle. And when you're on a more modern computer, not the weird virtual machine with the weird problems it has, then it makes a nice, swift fade out into black. But here we get to watch it fade out. And then it goes and triggers interrupt 19 hex, which is a BIOS feature for just like restarting the computer. So anyway, that's going to be it for this video. And unlike last time, I'm not going to be showing it running on a real computer because my real computers are having brain aneurysms right now. And they all just don't work for some reason. So anyway, but if you take my word for it, it does work on real computers, and in some cases a bit better than it does here. Anyway, that's going to be it for this video. I hope this is interesting to you, some novice or even high-level assembly programmers. Maybe it inspires you to make your own. Please make it not this terrible, and I hope to see you in the next one.